So inverse Z transform, but before we start that, I'm going to show you a short table of the inverse Z transform or the Z transform. So delta n is equivalent to 1, delta n minus 1 is equivalent to 1 over s, a raised to n times un is equivalent to 1 over 1 minus a z raised to negative 1. Actually, it should be z over z minus a, but then we multiplied it by z raised to negative 1 so that the z cancels out. So numerator becomes 1 as well as this one. So same goes with the last transform I'm included in the short table. Un is equivalent to 1 over 1 minus z raised to negative 1 if the function has been transformed to z. So we also multiplied it by z raised to negative 1. Inverse Z transform. Since transfer functions and common signals have transforms, which are rational, it is logical to apply the same technique developed for Laplace transform. So Laplace and Z transform are quite similar though, but they use different table. The process is still the same, converting it or transforming a given function or given sequence into a much easier function. So in Z transform, it is from continuous time domain to discrete time. So Z Z to n, actually it's like from n to z to samples. So here we have capital X of z, x capital X, which indicates that a function or a series has been transformed to z is equivalent to 2z over z squared minus 1. So we just factored out the denominator here so that it becomes 2z over z minus 1 times z plus 1. So by partial fractions, we're just going to separate it. So capital X of z is equivalent to a1 over z minus 1 plus a sub of 2 over z plus 1. I read it as over because I already multiplied 1 and a sum of 2. So one can compute the coefficients of a1 and a2, but the rational function 1 over z minus 1 and 1 over z plus 1 do not appear